Hi everyone! So for this video, we're gonna practice answering some problems on partial differentiation. But first, before we start, some reminders. First, make sure you have already watched our lecture video on partial derivatives. And of course, you are welcome to pause or play this video anytime according to your own pacing. Okay? So recall, no, that before in Math 21 or in your previous calculus courses, given a real valued function, you discussed the derivatives of that function. And since now we're already dealing with multivariable functions, you've learned from the lecture that we also have an equivalent concept of derivatives called your partial derivatives. Pinagkaiba lang po, since hindi na lang iisa yung variable ng ating function, no? Iba-iba yung derivative ng ating function with respect to each of its variable. So nagmamatter na po in which variable, no, are we differentiating with. Okay? So, kung tatandaan nyo, here are the notations that you've been using for the derivative of a real valued function. You have f prime of x, dy over dx, d sub x. No? Dun sa partial derivative, for example, if you have a function of x and y, so syempre, no, yung derivative niya, pwedeng with respect to x or with respect to y. Now, yung derivative with respect to x is denoted these ways. So, pwedeng f sub x, pwedeng partial ni f over partial ni x, or partial ni z over partial ni x. And then you have d sub x, or partial over partial ni x nung function. Or, kung with respect to y, very similar lang, just replace x with y. So, you have f sub y, partial ni f with respect to over partial ni y, partial ni z over partial ni y, and so on. Okay, so those are the notations we're going to be using for partial derivative. Okay? So, tatandaan nyo din, before that you had your limit definition for your derivative of a real valued function defined by this limit. And if you want the derivative at a certain value of x, no, at x equals c, well, you can either compute this limit and plug in x equals c, or pwede rin itong definition na to, no? This definition outright computes the derivative at x equals c. No, yung ating partial derivatives also has equivalent limit definitions. So if you have a function z equals f of xy, yung partial derivative with respect to x is defined by this limit. Very similar lang, no, doon sa limit, no, sa real valued function, except nagkaroon lang ng y, no, but y remains untouched. Tapos yung sa una, x plus delta x minus dito x over delta x pa din. Very analogous, yung f sub y mo, defined this way. This time, as delta y approaches 0, no, we get the limit of f of x plus y plus delta y. This time, yung x yung remains untouched. Tapos yung y, yung nagbabago, no, y plus delta y, tsaka y over delta y. Okay? And if we want to find the derivative, the partial derivative at AB, no, at x equals a, y equals b, well, you can compute these partial derivatives and plug in x equals a and y equals b. Or, meron din siyang equivalent limit definition that outright computes the partial derivative at AB. So, yung f sub x of AB mo is defined this way. So, very similar lang dito sa ating f prime of c sa real valued. No? We get the limit as x approaches a. No? Si b, ipa-plug in mo na agad. No? Yung sa first load, dito sa first term, f of xb, so you replace all y with b, but retain x, minus, this dun sa second term, ipa-plug in mo na yung both a and b for x and y, respectively. Yung f sub y naman, we get the limit as y approaches b this time. And in this case, yung a naman yung ipa-plug in mo agad to both terms. However, doon sa first term, you retain it to be y. Sa second term, you also plug in b na. No? And then over y minus. Okay? So, of course, provided that these limits exist. Okay? So, let's have this example. Now, I want the derivative with respect to y of this function. So, let's just use the definition. Limit as delta y approaches 0 of this. So, yung f of x, comma y plus delta y, I just retain x as is. However, I replace all y with y plus delta y for this term lang naman, no? So, doing so, yan, yung lahat ng y, ginawa ko lang y plus delta y. Minus, ito f of x, y, so siya mismo, minus yung function mismo, no, na negative 5y squared plus 3xy over delta y. And then simplifying, etong binomial, pag in-square ko to, I get y squared times negative 5 here. So, I get negative 5y squared. Yung second term is twice the product. So, 2y delta y times negative 5, I get negative 10y delta y. Again, sasamahin si y and delta y are different variables in this case. No? And then yung last term is delta y squared, no, times negative 5. That is negative 5 delta y squared. Tapos itong 3x, distribute ko lang dyan. I get 3xy plus 3x delta y. Minus this, so distribute ko lang yung minus dito. I get positive 5y squared minus 3xy over delta y. So may mga magka-cancel na term. Itong negative 5y squared magka-cancel with 5y squared here. Itong 3xy magka-cancel with negative 3xy. So matitira itong negative 10y delta y minus 5 delta y squared plus etong 3x delta y over delta y. Now, lahat ay may delta y, so I can cancel delta y para mawala yung ating denominator. Doing so, I get negative 10y na lang ito, no, kasi yung delta y nag-cancel. Ito, mababawasan ng isang delta y. So, negative 5 delta y na lang siya. Tapos ito, mag-cancel yung delta y, 3x na lang. And again, delta y is, we're getting the limit, no, with respect to the variable delta y. So we just replace all delta y with 0. So we get negative 10y plus 3x. Okay? So that's the partial derivative with respect to y of your function. However, no, you might find it tedious, no, to use that definition every single time we're computing the derivative. So, ang hirap niyang gamitin lagi, di ba? So, you've learned from the lecture din na pag nagko-compute ka ng partial derivative with respect to a variable, hindi mo na kailangan gawin yung limit definition. No? Ang gawin mo lang, i-treat mo na constant yung ibang variable. No? Tapos, mag-proceed ka na para ka lang di-differentiate ng ng single variable, ng real valued function from Math 21. No? Doon sa variable na kung saan ka lang di-differentiate. Okay? So, what do I mean? Halimbawa, using the same example, gamitin ko tong shortcut na to. So, I'm differentiating with respect to y. So, I will treat x, no, as a constant. Tapos, magiging, ano na lang to, function ni y. So, para ka lang babalik ng Math 21. Derivative with respect to y, sa ating first term, baba ko yung power 2, I get negative 10y. Sa ating second term, 3x is the coefficient of y. 3x is a constant, no? Times derivative ni y, which is 1. So, I get this derivative. Similar lang sa ating nakuha sa limit definition, pero this is faster and easier, of course. Okay? Sige nga, let's apply this technique on the following examples. So, for the following functions, we are asked to find both the partial derivative with respect to x and with respect to y. Nahin ko to, no? So, partial with respect to x tayo. So, I will treat y as a constant for this case. Tapos yung x yung aking variable. So, halimbawa, itong ln 4x plus y, yung derivative ng ln ay 1 over, di ba? So, ito ay 1 over 4x plus y. Tapos, derivative na sa loob, derivative ng 4x plus y. So, derivative ng 4x ay 4, yung y constant lang. So, 0. So, I get times 4. Plus, ito, second term, nilabas ko na to, no? Kasi constant lang naman ito with respect to x, no? Dahil nga yung y ay ginawa muna natin constant. So, labas ko muna to, tapos kunin ko na lang yung derivative ng e to the minus 2x, which is just negative 2e to the minus 2x. So, just simplifying a little bit, no? Itong 4, tinaas ko lang sa numerator, tapos ito inayos ko lang. So, I get minus 2e to the minus 2x, cosine squared of 3. So, napakabilis lang po. Imagine, no, using your limit definition in a function as complicated as this. So, thankfully, we have our shortcut. Next, f sub y naman, no, isa pang pinapahanap sa atin. So, itong loob ng ln, may variable y pa din. So, differentiate pa rin natin siya. No? 1 over 4x plus y times 1 na lang. No? Kasi yung derivative ng loob, yung 4x plus y, derivative ng 4x, 0. Derivative ng, kasi constant lang siya, derivative ng y is 1 lang. Dito naman sa ating second term, itong e to the minus 2x yung constant, so labas ko muna siya. Tapos ito yung may variable y, so ito yung i-differentiate ko with respect to y. But ang derivative ng ating cosine is negative sign. Tapos derivative ng nasa loob, chain rule tayo. Ang derivative ng square root is 1 over 2 square root. So derivative ng square root of 3y is 1 over 2 square root of 3y. Tapos, derivative pa nung 3y, which is 3. Okay? Again, ang derivative ng cosine, tapos nasa loob, yung square root, tapos nasa loob pa ng square root. And then, ito na yon, simplify lang natin. I get this. Tapos, ito, na e to the minus 2x, iangat ko lang kasama, itong e to the minus 2x, tsaka itong sign, angat ko lang sa numerator. No? Tapos, kasama nun, ito, ginawa ko lang minus because of your negative sign. Okay? Good. Let's proceed to your next example. Given this function, I want to get the derivative with respect to x and with respect to y. F sub x muna tayo. So, itong x to the 3y has an x. Tapos, itong tangent inverse may x din sa loob. So, I have the variable x in both terms. So, I might need to use product rule. So, recall product rule. We copy the first term. Tapos, derivative ng tangent inverse. Ang derivative ng tangent inverse of x ay 1 over 1 plus x squared. So, yung tangent inverse ng something na to is 1 over 1 plus something squared. Tapos, chain rule, derivative pa nung nasa loob na to. Again, ang ating variable ay x, no? So, derivative na sa loob, derivative ng 5x is 5. Tapos, derivative ng 6x squared y is minus 12xy. No? Yung x squared kasi 2x, tapos yung 6y constant. So, 6y times 2x, I get minus 12xy. Okay? So, ito na yung first term ng product rule. Copy the first times derivative ng second. Yung second term is derivative ng first times copy the second. Derivative ng first, x to the 3y. So, yung x mo yung variable, yung 3y yung constant, no? So, this is of the form x to the n. So, power rule lang tayo. Paano nga tayo nagpa-power rule? So, baba sa tabi yung power, tapos minus po sa exponent. Okay? So, 3y x to the 3y minus 1. Okay? Tapos, times copy the second lang ito. And this is your answer already. No need to simplify. Okay? Good. Next, x sub y. This time, y ang ating ituturing na variable and let's treat all x as constant. Okay? Game. Copy the first times derivative ng second. So, tangent inverse pa din yan. 1 over something squared. Tapos, yung something na yan, chain rule pa tayo. Derivative ng 5x, 0. Constant lang yan. Tapos, itong sa minus x squared y, no, yung minus x squared yung constant, 6x squared, rather. Tapos, yung y, derivative niya, 1 lang. So, ito ay negative 6x squared. Okay? Plus, second term is derivative ng first times copy the second. Derivative ng first, kung kanina nag-power rule tayo, no? Kasi x to the n yung naging form. Ngayon, yung y na yung ating variable. So, exponential na yung parang dating dito, no? Kasi yung x mo constant. So, parang ang form niya ay a to the x na, no? Or in this case, y yung ating variable. So, yung derivative niya, hindi power rule lang. Hindi mo ibababa sa 3y. And then, 3y minus 1. Hindi ganito, no? Kasi yung variable mo nasa exponent, yung base yung constant mo. So, ito ay, ano po, extra 3y ln x. Diba? So, x to the 3y ln x yung ating derivative for an exponential function. Tapos, times 3 pa doon kasi derivative pa nung 3y. Kaya may 3 dyan sa tabi. Okay? Nagets ba yun? Tapos, times copy the second term lang and we get your answer for f sub y for number 2. Okay? Good. Tuloy-tuloy lang. Number 3 naman tayo. Oops. Okay, tama. F sub x ang ating kinukuha. X ang ating variable, but we have an x in the numerator, in the denominator. So, we might need to use quotient rule in this case. Okay? So, low di high minus high di low over low squared. Again, low, so copy yung denominator. Di high, derivative ng sinh ay cos. Tama? Tapos, derivative pa nung nasa loob. So, with respect to x ako nag-differentiate. So, yung 7y to the 5th ay constant lang times derivative ng x, which is 1. So, 7y to the 5th lang. So, this is my low di high minus high di low. Ito po ay something squared. So, baba ko muna yung 2. No? Power rule muna tayo. Tapos times yun nasa loob. Tapos yung nasa loob naman, di-differentiate ko for my chain rule. Again, x yung aking variable. So, 4y to the 4th is just 0 when differentiated. Itong negative 8x squared will become negative 16x. This is my high di low over low squared. No. Oops, this is to the 4th. Sorry. So, that should be to the 4th. Ano rin yan? Okay? Attention na. Okay? But that's your answer. Okay? Good. So, yung f sub y, I will leave it to you. No. So, just use quotient rule again since there's a y appearing both in your numerator and your denominator and treat x as a constant. Okay? Number 4. So, number 4, we have a function na kung saan yung variable mo ay nasa bounds ng inyong definite integral. So, you've already dealt with something like this also in your previous calculus courses. No? Yung meron kayong function na ang variable mo, yung input mo nandoon sa bounds ng integral. No? And anong ginagamit natin? Recall natin yung ating first fundamental theorem of calculus. No? If I have a function like this, no? Again, yung input kong x nasa bounds, nasa upper limit of integration, then yung derivative ng function na to is just f of x. No? Just take the integrand and change the variable to x. Tapos minsan may cases pa kayo na ganito, no, na imbes na x lang, some other function x yan, pwedeng x squared or something else, no, basta in terms of x. No? Ang ginagawa nyo kapag ganyan, ipa-plug in nyo tong function na to sa f, sa integrand, no? Yung derivative niya. Tapos, ito times nyo pa yung derivative ng g of x na yun. Di ba? Do you remember your FPOC? So, ito yung ating gagamitin dito. Parang ganito lang siya, no? Kasi, yung iba namang variable, ituturing mo lang. Although may y at may x, no? Yung isa naman sa kanila, ituturing mo lang na constant when you're getting the partial derivative. So, parang, babalik ka lang sa ganitong itsura. Itong A na to sa ating definition is any constant, no? This definition will still hold. Okay? So, gawin natin. Sa example na to, burahin ko lang ito. Oops. Okay. So, in this example, ang ginagawa niyo pa muna kapag ganyan, kapag kinumpit natin si f sub x, no, yung partial derivative with respect to x. So, yung ating y is constant, etong 1 over x, yung ating g of x, no, kanina. Tataas nyo muna dyan, no? Kasi yung definition na alam nyo is nasa taas yung variable. So, taas nyo muna siya. So, we flip, no, by negating, if you remember. Diba? So, flip natin, yung negate natin. Okay, so yung ating derivative with respect to x, no? So, it's just, ano po, ipa-plug in ko lang itong 1 over x dito sa ating integral, no, sa ating t. No? Tapos, chain rule times derivative ng 1 over x, I just get negative 1 over x squared. So, pagandahin ko lang ng konti, magiging positive yan, negative times negative kasi. Tapos, eto nilagay ko lang sa tabi ng radical, and this is my answer. Very easy lang as long as you know your FPOC from your previous courses. Okay? Gawin natin sa f sub y. F sub y naman, y yung aking variable. So, hindi ko na kailangan mag-flip tulad nito. No? Sa taas na si y, itong 1 over x is just a constant, no? Kasi nga, you treat x as constant. So, simple lang. Tapos wala ka pang ano dyan, no, chain rule na gagawin. Kasi nga, yung variable y lang yun nandito. So, diretso plug in lang si y. As simple as that. Okay? Good. Next. Number 5 is also similar. No? Gamitan lang din po natin ng ating FTOC. So, yung partial with respect to x, iwan ko na lang sa inyo. No? Dali lang yan, no? Taas ko lang yung x. I-flip ko muna syempre kasi nasa baba pa si x squared. No? Tapos, you proceed like what we did kanina. Yung y ang gagawin ko. No? Yung y, no need to flip as is na yan. So, plug in ko lang si log of y to the base 3 sa ating integrand na sign. Tapos, times derivative pa nung log y to the base 3. So, ang derivative niyan is 1 over y ln p. And that is my answer. Okay? Good. Now, let's have this example. Okay, so we are given a piecewise function defined this way. Kapag daw yung x, y, mo ay hindi 0, 0, ito yung definition. No? Dito may ipa-plugin si x at si y, pero kapag yung origin, or kapag 0, 0 yung inyong x, y, then the function value is 0. Now, I want the partial derivative specifically at 0, 0, and 0, 0. So, you cannot use your shortcut, no? Kapag piecewise function, you have to use your limit definition. Okay? So, kapag kinuha ko si f sub x, gagamit po ako ng limit definition. Okay? Pero ang gamit na natin yung limit definition na isa, yung outright na si yung f sub x of ab. So, this is f sub x of b minus f sub ab over x minus a, by a being 0 and b being 0 as well in this given. Okay? Okay. So, pag ginawa ko iyan, etong una, f of x 0, so, saan dyan papasok si x0? Saan ko ipa-plug in? Well, I'm letting my x approaches 0. Again, tandaan pag kumukuha tayo ng limit, no? We let the variable get closer and closer to this number. However, I'm not necessarily at that number, no? So, ibig sabihin, ibig sabihin, habang even x gets super close to 0, no? This x0, no? I will still choose this one because it's not necessarily at 0, 0. No? X is not necessarily at x equals 0. Okay? So, for this case, ang kunin ko po is itong function na to. Okay? So, I will plug in x0 to this. And then, for this part, f of 0, 0, ito na talaga yan. Yung 0. No? Over x minus 0. Or x na lang. Okay? So, itong first term, kapag kinuha ko, magiging ano na lang siya, 9x to the 5th over 3x to the 4th. I can cancel 9 and 3. I will have a 3 above. Tapos yung x to the 5th and x to the 4th, I can cancel. I will be left with the 3x. Minus 0 over x na lang itong sa ilalim. No? I can cancel x. This is just 3. Okay? So the partial derivative at x equals 0 or at 0, 0 with respect to x is 3. Okay? Of course, you expect to have a constant answer since you already want the partial derivative at a specific value for x and y. Okay? Punta naman tayo sa derivative with respect to y ng ating function. So, apply ko lang. F of ay minus f of ab, no? Over y minus b as y approaches b. In this case, may b 0. Game. Against a 0y, since y just goes near to 0 but not necessarily 0, 0y is still plugged into this, not to this. Okay? So, I replace all x with 0 and retain y. I get something like this. Minus f of 0, 0 is, of course, 0 itself. Ito na siya mismo. Over y, no, which is what y minus 0 is equal to. Doing this, ano mangyayari? Eto, zero naman na to. Etong 4y squared, pwede kong ibaba sa denominator para I get negative y cube over 4y cube. Canceling y cube will give me negative 1/4. No? Now,